Hello guys, welcome back to my channel. My name is Kenry Carty. Please remember to like and subscribe. Now today, we're going to derive a shortcut method for completing the square. And I'm going to start with what we have here on screen, which is the general form of the quadratic expression, ax squared plus bx plus c. Now, why is it important to be able to complete a square? When we complete the square, we're able to easily identify the turning point of a function, of the quadratic function that is. The turning point is critical because it allows us to determine the maximum value or the minimum value of the function, hence finding the range of the function. Now we can always do this with a calculus technique, but we're not focusing on the calculus approach at this moment. So let's get right into it. The first thing I'm going to do is to group these two terms, the x squared term and the x term. So in order to get this to be a perfect square, we're going to factor out the a. This is going to give me x squared plus b over a times x plus c. Now, let us recall what a perfect square looks like. If we have x plus m all squared, this is defined as a perfect square. And notice when I expand this, I'm going to get x squared plus 2mx plus m squared. Now, what you realize here is that the c term is half the coefficient of the b term squared. In other words, the coefficient of the x term is 2m. If I half that, I get m. So the c term is m squared. That is exactly what we want to do with this bracket. So for it to be a perfect square, I'm going to have to find half the b term and square it. So I'm going to have x squared plus b over a x. Now if I divide b over a by 2, what I'm going to end up getting is b over 2a. And we say this has to be a square term. Yeah? So let me just change this to a box bracket out here. Now in math, we're only allowed to add 0. So whatever we add, we actually have to subtract it. Now because I'm adding the b over 2a all squared inside, and bear in mind that there's an a in front of the bracket, so I'm going to have to multiply that by a as well. So outside I would have to subtract a times b over 2a all squared. Now the bracket, inside my bracket, I now have a perfect square. I'm going to have a into x plus b over 2a all squared. And outside we have c minus a times b over 2a all squared. All right, let us redefine this expression. So we can say we now have it in the form a x plus h all squared plus k. Now, if you look at this carefully, you notice that h would be equal to b over 2a. And outside you have k, which is equal to c minus a times b over 2a all squared. But bear in mind that b over 2a is actually equal to h. So we can say that k is equal to c minus a h squared. So technically speaking, there are only two things that we need to remember. That h is equal to b over 2a and that k is equal to c minus a h squared. We're going to do an example to show you. So here we go. Now what I've done is that I've written down my h and my k value, so I can at all times remember that. Now here we have a equal 2, b equal 8, and c equal 5. Now h is equal to b over 2a, so I'm going to have 8 over 2 times 2. H is equal to 8 over 4. H is equal to 2. Now k is equal to c minus a h squared. C is 5, so I'm going to have 5 minus 2, and h is 2, so we have 2 squared here. So this is going to give me 5 minus 2 times 4, which is 5 minus 8, which is minus 3. Now when we complete the square, we actually get it in the form a into x plus h all squared plus k. So all we have to do is populate this formula. A is 2, h is 2, and k is negative 3. And there we go. We have completed the square with the shortcut.